will discuss about the finite automata. We will see the model of the finite automata diagram. This we will call it as the input tape. This is the start's initial symbol and the end symbol. For each input tape, we have the read control. So this control we will define by using the arrowhead. So whenever we have the, for suppose, input string A, B, B, A, the finite automata, the read control head reads from left to right. The main thing of the finite automata that reads only from the left to right, that can't move the backward. So that means from the initial state to that will stop at the end of the symbol. So that we will be take care of the read control. We have the arrowhead to read the symbol step by step. Each and every symbol will be read by the finite automata. So from the left to right itself. We will see the finite automata, different types. So here we have the, whenever we have the finite automata, so we have the different types of the symbols, like initial symbol. So whenever we have the automata like this, so Q1, this is the initial symbol, we will represent with the single arrow. So where the execution, where the process starts, we are calling it as the initial state. Next we have the end symbol, that we are calling it as the final state. So initial symbol will call it as some initial state itself. So the final state will represent with the double circle. Next we have the dead state. So for suppose, whenever we reach the dead state, so we can't go back from to dead state to any state. We will stop at the state itself. That we are calling it as the dead state. But suppose if we observe the Q4, so from the Q4, we are not going to reach the any states. So that we are calling it as the dead state. So here Q1 is the initial state. Q4, whenever we are representing the double circle, we are calling it as the final state. Here Q2, we are calling it as the intermediary states. So initial state, final state, dead states are the states that are very important whenever we are drawing the finite automata. So coming here, output alphabets and the input values. So finite automata, we are discussing only without output. So here we are giving the input state like Q1, whenever the input alphabet 0, that we are moving to the next state Q2. Q2 on input alphabet 1, we are moving to the final state Q3. We have to draw the transition table based on this. First we have to take the states and the next state and the input alphabet. So here we have the states like Q1. Whenever the Q1, the input alphabet 0, whenever the input alphabet 0, the next state is Q2. So whenever we have the state at Q2 on input alphabet 1, the next state is Q3. Whenever we are at the Q3, so we are not going to go for the different states. So that means we are giving it as the epsilon. So Q1 on input alphabet 1, we don't have anything, 5. Q2 on input alphabet 0, we don't have anything. So we are calling it as just the 5 state. So we will see here how the transition table and how the finite automata will draw Q1, Q2. For suppose on input alphabet 1, we are going to the Q2, on input alphabet 0, we are taking to 0. Go with the next state Q3. So on input alphabet Q1, so on input alphabet 1 we are coming to the Q2. Q2 on input alphabet 0. So just I am taking the example on input alphabet 0. So we are coming to Q3. On input alphabet 1, the next state is Q1. So coming to the Q3, I am taking, so for both input alphabet Q3 itself. So draw the transition table now. So first we have to take the present state. Yes, yes, that is the present state. Input alphabets we have 0 and 1. On input alphabet 0 and 1, we are moving to the next states. So the next states. So present state I am at Q1. So on input alphabet 0, the state is the same state itself, that is Q1. On input alphabet 1, so we are moving to the arrow mark, that is to the Q2. So next, coming to the next state Q2. On input alphabet 0, so the arrow mark that is moving to the Q3. So next one, on input alphabet 1 and Q2, so we have the next state as Q1. So that's all about the outgoing edges of the Q2. Next, coming to the Q3, on input alphabet 0, the same self state, that is Q3. On input alphabet 1, the same state, Q3 itself. So this is the transition table we will call. This is the finite automata diagram. So for this, any type of the finite automata, so we have to take the transition table. So here in this, so coming to the finite automata, so the definition of the finite automata, so here we have the states like Q1, Q2, Q3. So these are the set of states. The input alphabets, we have 0, 1. So the set of states, we are taking it as the Q. Alphabets, set of input alphabets, we are taking it as the sigma. So next, we are moving from one state to the next state. That is the transition function. We are taking it as the delta. Next, we have the initial state, that is the Q1. So the very important for this finite automata, initial state and the final state, that is the Q1. The final state is Q3. Now coming to the definition of the finite automata machine that has the 5 tuples Q, sigma, delta, Q naught and F. So Q means set of states what we have taken in the diagram, like Q1, Q2, Q3. These are the set of states. And 0, 1, that is the input alphabets that we have taken on the transitions. And next one we have the transition function, that where we are moving, that is the arrow marks, that we are calling it as the transition functions. Next we have the initial state, that we have the Q1 and the final state. So these 5 tuples that will define the definition of the formal definition of the finite automata. Q, sigma, delta, Q naught and F. These all contains the finite automata formal definition.